We have another one for you, so we are ready?
Yes.
So please warmly welcome Yury Tsarev.
Thank you very much. I'm Yury. I work as QA architect for a company called Good Data. And today I would like to share our experience of building test-driven infrastructure. So overall, agenda is we will try to define a goal that we're going to achieve. We shortly cover a test kitchen project, which it is a central part of the story. We will deep dive into implementation at Good Data, how we bind in test kitchen with Docker and Serverspec, and I'll try to demo actual test-driven infrastructure change creation and some wrap-up thoughts why it does make sense to us. So the goal, we strongly believe in Good Data that infrastructure code should be treated as any other development code, and meaning that we're trying to apply best development practices there. For us, it means basically applying test-driven development approach for a Puppet code. And given this way, we try to shoehorn a process of naturally growing regression test suite. So Test Kitchen is an open source project written in Ruby, originated in Chef community. It's kind of test orchestrated thingy. If you attended previous talk, it was partially about Vagrant. So you can think of Test Kitchen like a test-oriented Vagrant. So it's very extensible and flexible. And basically, you can bake completely different test infrastructure using the same tooling. It has a fancy slogan. That's how they managed to sell it to me. Your infrastructure deserves tests too. And it's mentioned in a pretty nice book called Test-Driven Infrastructure with Chef. So a high-level overview how Test Kitchen works. It's really simple. It creates VM or container, runs configuration management code there, and runs any kind of test suite to verify the correctness of this configuration management code under test. So I try to reflect in this diagram, like Test Kitchen has three main modules, each one responsible for different thing. So driver is for creation of the instance under test. Provisioner is for application of configuration management code in kitchen terms and a verb converge. And a verifier to actually run a test suite. And all this happening into isolated instance under test. Oh, you can configure kitchen in a simple YAML configuration file. And these are main points of this configuration. So for driver creation, it has plenty of plugins. So anything from Amazon to OpenStack private cloud and down to Docker. For provisioner, the same approach. It supports Chef out of the box, but also it has external modules which support Puppet, Ansible, SaltStack, and maybe something else. They're emerging from time to time, the new ones. And verifier supports also out of the box popular shell testing frameworks and RSpec, one of the most popular framework in Ruby community, an extension of it called Serverspec for infra testing. Less important models is the transport, is the way how you actually deliver the testing code into instance, and a platform and suite is a way how to semantically organize your testing scenario so you can override and define some testing constraints using these sections. So we in Good Data made a choice and using these specific drivers. So we're using Docker driver, Puppet provisioner, SFTP transport, and Serverspec verifier. So just to give you an idea how our infrastructure test pipeline, automated one, works in Good Data. So first of all, when developer creates a pull request, it goes through a relatively fast test of Puppet catalog compilation, meaning it compiles catalogs for every type, like server role. We have described in our infra. And assuming that everything's fine, it promotes the code under test to the next level, which is a Test Kitchen. And Test Kitchen operates by provisioning Docker containers. It puts Puppet under test into Docker container, test suite there. We also use strict, we internally calling it shell mocking. It's a way to isolate things in container and get rid of external dependencies. I will elaborate on it a bit later. And giving this stage is green, the code gets merged to a relevant branch, and it basically goes to actual end environments. An important point that is, according to best continuous delivery practices, the same code the same code get tested, and exactly the same code got delivered into the production, and we also moving our tests together with our code, so instances get also tested in a real environment. And obviously there we have no any kind of mocking. So Docker driver, external model which supports provisioning your Docker containers as the instances under test. I will provide configuration chunks here and there to get you a feeling how it actually easy to configure. So in this example, we pointing the Docker driver to our private Docker registry, defining platform for compatibility, just to give a driver a hint which packer manager to use and so on. And some provisioner command which prepares instance for clean states. Here we just cleaning caches of our package manager. Next step, convergent. So Puppet provisioner, also external model. It gets a Puppet into instance under test. And the most important part from a test perspective is actually a facility to override Puppet facts to create interesting test constraints. So here is an example of our Puppet provisioner configuration. We basically define where to get Puppet code from a kitchen point, and we installing custom facts, meaning that we are rewriting some actually used facts in our code. Meanwhile, we faking out some external things, like for example, this free IPA one-time password. We just faking it out, and on this level of overriding. In provisional level, it means that these facts will be override for every instance under test. Meanwhile, we have ability to override on per instance level later. So transport. Original implementation is really underperforming. So luckily, there is a already project available called Kitchen Sync. And basically, default SCP, we replaced it with this TP and dramatically reduced the upload time. But the reason for that is not that SCP is generally worse than SFTP, it's just Ruby implementation in standard library NetSSH is somehow horribly underperformant for SCP. Kitchen Sync also provides rsync support, but it more complex, requires SSH agent, separate one, so we made a choice of less complex solution. So here we are just overriding it, and that's it. Serverspec test suite. Basically, Serverspec deserves a separate talk. It's a very rich testing framework. It's extension of RSpec. Sorry, I need to get some water. It is extension of RSpec, and it provides a rich abstraction of the way how you can test your infrastructure. It's absolutely independent project from Kitchen. You can use it standalone. And the way how we do it, we keep in tests together with actual infra code, and this way developers can create consistent, semantically consistent PR. So test lives together with production code. So several examples of Serverspec to give you a feeling how it looks like. It's just chunks randomly picked from official documentation. So you can see that you can test really simple stuff like file exists and it is directory, to more abstract things like configuration of running container, simple network stuff, kernel capabilities. And I would like to highlight a command resource type, which is actually most flexible one, because you can put any kind of command, test it for stdio, test it for exit status, test for stdr, and so on. And this way you can build really customized stuff out of that. At one point of time, you would probably need to also abstract and create additional custom Serverspec resource type in Ruby, but you have a big room until you really need it. So how to actually bind Serverspec with Kitchen? So out of the box support from a test kitchen project is called Buzzer. It's kind of thing that runs, supports multiple testing frameworks, so it executes them. But it's very simple. It's not. It doesn't scale, and it's not very extensible. So we went more advanced way. Here in the link, one great guy created like blog post, like good reference implementation of Serverspec, and we borrowed code from him, and we're developing our test suite implementation on top of that. And our implementation matured a lot, and we will soon open source it. But it didn't happen yet. How we actually execute Serverspec, given that we have this custom test suite executor, we're interested into invocation of it the same way as in production instances, for example, in the same way in a Docker test container. So we just reused shell verifier. We just allows you to run shell and do some stuff in the test step. And we running the Serverspec there, overriding control variables. Our implementation can produce results in JUnit, and so we can easily plug it in Jenkins. This tag, skip in Kitchen, if somebody familiar with Serverspec, it's standard facility to actually skip the tests that explicitly mark with some text. So the use case for that some of the tests written in Serverspec, in our case, are really end-to-end, and they work only in more like real environments, and they do not make sense in Kitchen. Meanwhile, they make perfect sense on an actual environment. So we keeping still the same test suite, meanwhile not polluting the results. Shell mocking. So giving developing this testing infrastructure, we face the problems of external dependencies and some Docker-specific stuff. So the way to solve it appeared to be relatively simple. So we just mocking the executables that are not working during converge and that are not important for the testing scenario. So it's a simple reverse script. It plugs in during the test instead of package manager, and assuming that the mock is defined, it will replace with a defined mock. And given that there are no defined mock, it will just pass the call to a real package manager, and everything will work fine. So the format is really simple. Package pass to actual binary or any kind of executable and the mock contents. So to give you a mock little picture, it's a real examples that we are using. So package API client install. In a test scenario, we definitely don't want to register container in free API. So we just simply mocking it out, and the resulting mock will contain very simple bash script to just fulfill the configuration files and key it up. And the most simple way to do it is like we are doing with 3SD. Just define package, define executable, and our tooling will just populate the whole I'm a fake something. And in this way, it's just return exit status 0 success, and it's fine for Puppet. And meanwhile, it could be just been true, but here it's just for logging facilities. So also kernel capabilities. Sometimes it's necessary to not really create a mock, but in this, to actually use kernel capability is a way to allow root access, but only partial, if to make it like a nutshell. So in this provided case, we're using specific capability, capsys resource, and our manifest, for some of our manifests that using nproc control limit. So this way actually allows container to use this kernel param, and it more makes the Puppet run green. And if you are going to use that, I highly recommend to cmon capabilities exactly for the kernel under test. You're using in testing scenario because these kind of capabilities are heavy deviate from kernel to kernel version. So how to actually define Puppet type in Kitchen? So Puppet type, in our meaning, it's just server role, instance role. And it's not a kind of Puppet resource type, it's just instance role in our code infra, our implementation. So we have this control entry point called EC2 data type, which is the name of a role of a type, basically. So we just are writing on a platform instance level, and Puppet code, we will use the proper way of execution. And assuming that you're doing it first time, probably it will fail. You make a decision if you need some shell mock, add some mock, or add some kernel capability, and then repeating, and when it's in green, your type is ready for testing. And you can start happily writing tests. I will try to actually demo that, but given my quite big experience in failing the live demos, I have a recording for you. So, nope. Is it visible? Ah, it's not this one. Okay, pardon me. Yeah, just a sec. Yeah, this is recording. Yeah, so here we starting from scratch and making kitchen list. Like to see the list of our adopted types. We have a Zulu gating type pre-converged for the sake of time constraints. First, we're making verification running existing tests. All is green, 82 are fine. Then we're adding new test, which is supposed to be failing one, implementing a simple feature. Basically, currently, we are going to just add HTTP daemon for a Zulu Puppet type. Yeah, so the idea cell is very simple. Should be enabled, should be running. We're running the freshly created tests. It should obviously fail, and it does. It reflects that we have no HTTPD. And now we're going to implement the actual infra code. We are really going to. Yeah, so basically this is already Git changes. So you see we just included HTTPD model into actual Puppet manifest. And meanwhile, we have a test. Very simple example, just to have a picture. So now we are going to actually deliver our code into instance under test, meaning kitchen converge, run. So it will rerun the Puppet within an instance. Yeah, so I will rewind here because it's just Puppet run. Yeah, so image is converged, instance is converged, sorry. And now we running verification run again. And it's green. Now it's not 82, 84 tests and a new test pass. So our code fulfills the testing scenario. And if you want to double check things, we can always log in to testing instance, kitchen login type, and investigate with a standard shell. So that's basically it for demo. So again, standard red-green refactor thing applied for infrastructure code, as you can see. So the question I frequently get after showing this is why I should write the same thing in both in Puppet and some kind of testing tool, like Serverspec in this example. So I can assure you that it really pays off at scale, meaning that if you have many of replicas, for example, web ones, and you deliver a new change at huge scale, like good data has, something subtle can happen, like Puppet will be reporting all green converge, meanwhile Serverspec is this safety net that will tell you that something got wrong on a couple of nodes. So it's really helpful in this scenario. Again, Next huge point is TDD. It really makes the flow and allows you to write good testable code. In case of Puppet, it's more like you have a ability to avoid the idempotency problems and so on during developing your manifests. And on top of that, even that is already useful, you can create more tests that would test an actual outcome, which is way beyond the Puppet. So here in this example, we test in actual provided endpoints locally. Meanwhile, we have a pretty good smoke tests that will assure that everything is configured properly, Kerberos for HTTPD in this case. Yeah, it's Serverspec plus a bit of Ruby, but really basic one. So I don't think that it can be a blocker for somebody. So wrap-up thoughts, benefits, Scratch environment. So testing from Scratch is really important from quality perspective. Isolation, we're able to actually test everything in Docker even before it gets to any kind of real machine. Easy to test permutations. It means like basically standard, like maybe manual Puppet code test would look like. You're writing new code, you're making Puppet no-op on a real node, and you see that chunk is fine, you're applying it, and everybody happy. But a couple of days later, a fresh node of the same type is getting redeployed, and something gets wrong. So Test Kitchen provides you ability to actually test both scenarios and in a very automated way. Resource efficiency. Yeah, standard Docker selling point. But for us, we're running private cloud, OpenStack based, and it's really important for us to not, for example, deploy 10 full-fledged VMs. Instead, we can run the same 10 testing scenarios within one VM in Docker containers, and this VM will be just Jenkins slave. So we are packing things properly. Test-driven approach, already discussed, and pretty important part that, as you noticed in a demo, we actually got feedback even before making a Git commit, even local one. So you can just test things right away. Yeah, and assuming that you amending all your code with a supporting test, you have a good regression test suite naturally growing. And all these things are really easy to plug into things like Jenkins and create this continuous delivery pipeline. So, open source side of things. Actually, all the things I described didn't come for free. We were missing a lot of features, and we were adding them in all the projects I mentioned. We have at least one patch in, and it was a great experience to be to become a Kitchen Puppet core contributor. Small project, but I'm very, very proud of it. So we contribute a lot to upstream. So what's next in this story? As I mentioned, resource efficiency, yes, but still we have a lot of types, and we can't allow ourselves to run whole regression test suite for all types on every PR. It's just not possible, and it's anyway long feedback loop. So we're using another open source project called Puppet Catalog Div and some automation on top of it, which basically will create a catalog, Puppet catalogs compiled on top of stable head branch, plus and another bunch of catalogs from PR, div them, and from that you will get a type of affected list. It is by itself useful as a feedback for developer, assuming that in this list some type appears that developer didn't expect that his code will influence that. And this list can be used as input for Test Kitchen, and will run only relevant types, and it will make things much faster. So, not an agnostic approach. Basically, as you noticed, driver can be anything apart from Docker. Provisioner can use plenty of popular configuration management solutions. Serverspec itself is not bound to any kind of configuration management, so you can test Puppet, Chef, whatever, with this testing framework, or even manual change if you like. So it's really a good amount of flexibility here. And for us, it means that we really can, assuming we have this huge test safety net, we can make huge moves, like move from Puppet to somewhere else, or testing major Puppet upgrades from version 3 to version 4. So it really pays off. It's a good investment. So I would like to thank you for your attention. I tried to make the last slide somehow useful with links to project discuss, and I would like to answer any questions. Anybody? Yes?
What support is there for testing multiple systems at the same time? For example, you have a deployment where you need to make sure that Etsy host matches between server A and server B. Is that something that you can do with this? Or are the tests always specific to one system?
The main unit is a server role. So we are testing. We have a prescribed amount of tests based on that role. So we are not testing Puppet models. We are testing actual infra and these provisioned roles of servers as a whole and infrastructure as a whole in the end. So this way, we can assure that our infra is in a good shape. Did I answer your question?
I think so.
Yeah, great. Thank you. Anybody else? No? So thank you very much. Да. Yeah? Thank you very much.
Much more time.
Yeah.